Morning, everybody. Video 6, chemical bonding, ionic formulas from their names. We are going to use the charge cancellation rules, or the crisscross method, to find the formulas from the names. So we just learned last video how to name these things from the formulas, and this video is going to teach you how to go backwards. If we go forwards in this unit, we can go backwards. So all ionic charges have a net charge, or all ionic compounds have a net charge of 0. This means that all the pluses and the minuses must cancel out. We're going to use this to our advantage to work backwards. Okay, that's what this crisscross method's all about. And it's really just a fast way to do the algebra. So here's a quick example, and you'll see what I'm talking about. Sodium chloride. After about 10 times of doing sodium chloride, you're going to know exactly what it is. It's yummy. I put it on my French fries. So do you, probably, I'm guessing. First is the element symbol. So sodium's Na and chloride was chlorine. Remember, it's ending in "ide" now to tell me that it's bonded. So I got sodium and I have chlorine. Now I'm going to look up their charges. Sodium's easy. It only has one charge. It's +1. And I remember from a video or two ago, it always goes plus charge, then minus charge. And in that case, chlorine only has one charge if you look it up on the periodic table, possible, which is -1. It has a bunch of plus charges after it, possible, but we need a plus and then a minus, and chlorine only has the one minus. Okay, so then we're going to just crisscross down the charges. Notice though, only the numbers, not the actual charge. I can't have -1 atoms. That doesn't make any sense. Okay, I'm just going to figure out real fast how many +1s do I need to cancel out with a -1. Now this seems pretty simple, but I want to show you the method. In the next example, it'll get a little bit more complicated, and you'll see that this method still works perfectly. I'm going to bring just the number down, and bring just the number down, not the symbol. And the nice thing about chemistry is I don't have to put a 1 ever as a subscript, because the fact that Na is there means there's one of them, minimum. And if there's 2, then I have to put a 2. If there's 3, then I have to put a 3. So this just becomes NaCl. These combine in a ratio of 1 to 1. 1 plus charge with 1 minus charge, and I make NaCl. All right, let's try one with a polyatomic, and notice that these rules are all going to just go through the same. So calcium phosphate. First things first, I need the symbols. Calcium Ca. When in doubt, check E out. Notice phosphate ends in an ATE. It's not an IDE. IDE lets me know that it's an element that's bonded. Here I see ATE, so you're not going to see that on the periodic table anymore. That is a bonded polyatomic. Look in table E. It's not on the periodic table. Now I find the charges. Also on table E for PO4, calcium only has one charge, +2. Phosphate is a -3. And so now, how many +2s do I need to cancel out with a -3? Now, I'm sure we've done some of this math before. The correct way to do it is greatest common factor. So the greatest common factor between 2 and 3 is 6. So I need to multiply +2 times what to get me to 6? Well, it's 3. But the easy way to do this, guys, is to just crisscross the numbers down. And you'll see that's where I get the 3 to multiply the 2 by. So I just bring the 3 here and take the 2 over there. And now I've got 3 CAs and 2 PO4s. I have 2 -3s, -6. I have 3 +2s, +6, total, plus charge. +6 cancels out with a -6. And I get a compound that looks like this. Ca3, PO4, 2. Now notice, the PO4, the 4 tells me how many oxygens are in the phosphate, and then the parentheses tell me that that one phosphorus to 4 oxygens is a group, polyatomic ion. If I need 2 polyatomic ions, I put parentheses around and put the subscript outside of it. That works very much like in chemistry, the way it works in algebra. If you were to say 6 parentheses x plus 2 parentheses, you'd know what to do with the 6. You would distribute. Well, in chemistry, we do distribute backwards. Okay, so when we start counting atoms, next unit, you'll get a feel for how do we distribute that 2 backwards. But right now, you need to know that that means there's 2 phosphate groups, which is a polyatomic ion. They stay together. They do not separate. Okay. Okay. Next one. This one is the transition metals. So this is where the Roman numerals come into play that we just learned in video 5. I see it says iron 2 oxide. and the Roman numeral is the charge. So I've done iron enough that I know it has a +2 or a +3 charge. The Roman numeral 2 is telling me pick the +2 charge. So let's go through the paces. Element symbols first, Fe and oxygen. Oxide, just a plain element, came from oxygen. Okay, you got to be able to make that step. Then we do the charges. And here's where things get confusing because Fe can be a +2 or a +3 on the periodic table when you look it up. But this Roman numeral told me it's the 2. So now the 2 wins. So it's Fe +2. Oxygen has a -2 charge. It's minus. It's actually the only one on the list, right? Very rarely will oxygen be a -1. We'll get into that if we ever get to it. Crisscross down the charges only, or the numbers only, not the charges. And I get 2 to 2. And notice that is a 1-to-1 ratio. So here's the next piece. Ready? We don't write Fe2O2, we write FeO. It is a 1-to-1 ratio. So we do have to reduce these charges. So I want to make sure we had an example where we had to reduce the charges. You might want to write that down. And a side note, that if the charges will reduce, we do that. Not inside parentheses for polyatomics, though, only on the outside. Okay. Now I have a transition metal and a polyatomic ion. And polyatomic ions are nothing to be upset about. They actually help us understand the charges very quickly because when I don't know the charge on the copper or I don't know the charge on the iron, there's only one choice on a polyatomic ion. So that does help limit things. So first symbols, copper Cu, sulfate ending in that ATE, look it up. There it is, SO4. Pull my charges. Copper could be a +1 or a +2. Again, I see my Roman numeral tells me it's the +1, not the +2. So I have to pick the +1. I can't, the +2 would be easier because look, the SO4 is a -2. Okay, but I can't pick the +2. I have to pick the +1 because of the Roman numeral. The Roman numeral is the charge. Okay, crisscross down the numbers and not the charges. I bring the 2 there. I need 2 +1s to cancel out with 1 +2. And then I get this CuSO4. Now notice I didn't have to write the 1 after the SO4. The fact that it's SO4 shows me that it's a polyatomic ion and there's at least one of them. Here I did put the parentheses in for you just to help pop out the fact that it's a polyatomic ion. When there's just one, you can actually write Cu2SO4 and leave it like that. And eventually we will drop off the parentheses. The parentheses only need to be there if there's more than one. That's by rule. If you put them in, I'm not going to ding you and take points or nothing like that. But you don't have to. So technically, that is doing too much, just saying. And this might be it. We donezo. So practice coming up with formulas, crisscross method. If it doesn't make sense, we'll try and ask questions in class. We'll try some more, and hopefully it'll click.